Hello folks, I'm Mike, K6EEP in Tracy, California, and this is my FT2000 in the ham shack here at home. And I threw my QSL card up there so you could see kind of a picture of me. This video is to explain and show how I repaired the preamps in my FT2000. Apparently other people are having this problem as well. I found that RFI was getting into the radio and causing it to blow those preamps. I've replaced a total of 9 of those transistors. There's 2 transistors in the preamp section. This is how I test for a blown preamp in the FT2000. If you blow the first transistor, you've disabled both positions of the preamp. They are in series, so amp 1 and amp 2 will become inoperative. And this is how I go about testing for that situation. So first thing I do is I use an AM broadcast station because they make kind of good signal sources to do the testing with. So I have them stored in memory here, so I just hit memory. We're in the, let me zoom over to that portion of the radio. Okay, so we've got an S meter reading here of about 5. We're in the on mode, which is the bypass mode of the IPO section here. What you're looking for is when you go to amp 1, like I just did, see how the S meter jumped up? If you're at S5 in the on mode and it doesn't jump up, if it goes lower, you've got blown preamps. Of course, you go to amp 2, it should get even higher. Same thing, if it gets worse than in the on mode. Remember, in on, we have an S5 reading. Then you know you've blown a preamp. Alright, I'm going to show you some of the equipment I use to do the repairs, because once I drag the radio out, there won't be any room on the desk. So this is the soldering station I use. It's a Hacko 936, temperature controlled, and this is the iron. The tip on it is pretty small. The solder wick I use is 55 thousandths, or this stuff is 50 thousandths. That's 0.050 of an inch width-wise, and it's comparable. It's actually wider than the tip by, I'd say the tip is about 30 thousandths wide on the iron here. And what I'll do is I'll take this solder wick, get some needle nose, get the very end of it, and bend it 90 degrees so you have like an L shape. It's kind of hard to see in this. I'll do another picture that blows it up. Then when you go on the board, you can put the tip of the soldering iron right in that V on the L, right in the center there, and it lets you kind of push it around a little bit right where you need it. The other thing I use is a nice set of tweezers so that you can get in, kind of lift up on the transistors to pull them out. These are pretty good ones. And I use my rosin paste flux. This is really yucky. I'm not going to open it. It got hot. It's a long story, but anyway, it works. The paste I use, I would probably use the liquid stuff, but I can't find it, so this was the only thing I could find. But in retrospect, if you use the paste, you can put it on the legs of the transistors and it doesn't run down like it would with the liquid flux. So it works better. And then you use like a toothpick or something to apply it. Just put little dabs on the legs of the transistors. And that's very important when you're using solder wick. You want to have plenty of flux because it helps it run into the wick, and it uses a minimum of heat when you do that. It also kind of makes that thermal bond between the soldering iron tip and the flux happen quicker. If you just use the flux alone and the tip of the iron, it wouldn't work as quickly, and you'd transfer a lot more heat to the board, and that's not desirable when you're dealing with such small components. The pads on the board or the runs will just lift right up, and then you've got to fix them, and it's a real pain in the neck to do. So that's basically what I use, and now I'll move the radio out, take it all, open it up for you. When you open up the radio, I was using a power screwdriver, but I ended up kind of messing up some of the screws, so don't do it. I mean, I would like to keep my screws looking halfway decent, so I just switched over to a regular old screwdriver. and that seems to work the best. See you in a bit. Alright, here's the part I kind of hate. Got the radio outside, external case off right now, and I have to remove, I flipped it upside down, I have to remove this metal cover here. All these silver screws have to be removed, and there's a bunch of them. The screws are actually like a self-tapping metal type screw, so be careful when you do this, because if you strip out the hole, it's not going to be something you really want to fix. I think if you had to fix it, I would probably tap it and put a regular machine screw in there. I don't know why they were so cheap and just use this. I guess it's fast to slam it together that way, less work, because they don't actually have to drill and then tap the hole. All they have to do is drill the hole, so maybe from a manufacturing point of view it's cheaper. So anyway, I got to do that. I'll do that next, and then I'll fast forward for you. Some things of interest: there's a battery down in here where I guess it stores your memory information, and there's actually a hole in the bottom of the case, so if you want to check the battery voltage, you can just run a multimeter right through the hole down and touch this battery between there and ground somewhere, and you can get an idea what the voltage is. Alright, so I'll be back in a sec. Okay, here's the grand unveiling. Ta-da! Alright, I've spent a lot of time in here. Let me get in for you a little bit. One thing you'll notice over here now is that red LED. That means that I have the power supply turned on still, because I like to live dangerously. It takes a little while to bleed down. If I can find the switch, there it is. So I've turned it off. It'll take it a little while to bleed down, and you can see the battery over here, a little watch battery type thing that keeps your memory information. So let's sweep over to the side that we're interested in. It's actually right in there. First thing I'll do is, we're looking in this area right here, and I want to pull this connector off because it's in the way. You start soldering, you don't want to burn it up. So I usually do this and fold it out of the way. Let me move around here so you can see it. In fact, I'll zoom out more so you get an idea where we're at and everything. Now remember, this is the front of the radio, and it's upside down. As we move in, I just take this cable and stick it between this piece of metal and this shield can, whatever. Alright, let's look. This is where on the board the thing is located. Here's an actual pointer to the location. Here's a zoomed in shot of where we're going to be working, and another zoomed in shot. The items with R24 are the transistors, which are shown here on a grain of rice. And in comparison to a US dime, so you get an idea how big they are. Here's the actual part number, NE85633B. This is the solder wick I use, and this is the solder I have. It's actually got lead in it. There's the solder iron tip with the wicking on it. This is the diode limiter that I created out of 2 silicone diodes, and that's where it's mounted inside the radio. And here's another shot of that, a little closer. You can see test point 25 there on the bottom.